In this video, we shall study Euler's theorem and how to apply it on homogeneous functions. Since Euler's theorem can be applied on homogeneous functions only, this part is dedicated to identifying given functions to be homogeneous functions or not. Further, we shall study various useful deductions of Euler's theorem. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Consider function u of three independent variables x, y and z, which is x upon y plus y upon z plus z upon x. We replace small xyz by capital XYZ. So f xyz will be x upon y plus y upon z plus z upon x. Next we replace this capital X by small xt, capital Y by small yt, capital Z by small zt. So u becomes f of xt, yt, zt, which will be xt upon yt plus yt upon zt plus zt upon xt, which is by taking t common from both numerator and denominator, it will be again x upon y plus y upon z plus z upon x. So finally we get u equals f of capital X, y and z equals, cancelling this t, it will be t raised to 0, and for this x upon y plus y upon z plus z upon x, we write this f of small x, y, z. So when we could write f of capital X, y, z equals some power of t, in this case 0, times f of small x, y, z, then such a function, that means this function is known as homogeneous function. And this being in terms of only x, y, z, it is also known as algebraic homogeneous function. Consider a function u of two independent variables x and y defined as square root of x square plus y square. So we write u as f of capital X, capital Y, which will become square root capital X square plus capital Y square. Next we have to replace this x by small xt and this y by small yt, so that u becomes f of xt comma yt equals square root of xt square plus yt square. That will be square root of t square into x square plus y square, which will be t raised to 1 square root of x square plus y square, which is nothing but u equals f of capital X, capital Y, capital Z, which finally will become t raised to 1 f of small x comma y, the original function. Therefore, this function is homogeneous with degree 1. Consider function u f of x, y, z defined as log of x cube plus y cube upon x square plus y square. In terms of capital X, Y, Z, this will be log of capital X cube plus y cube upon capital X square plus y square. Next we will replace xyz by small xt, small yt and small zt, so that f of xt, yt, zt will be log of x cube t cube plus y cube t cube upon x square t square plus y square t square. This will be log of t into x cube plus y cube upon x square plus y square, which is not same as t raised to 1 because here it is t raised to 1 f of x, y, z, which is this function. Hence, since given function cannot be written in the form some power of t f of x, y, z, this is not a homogeneous function. What about this function u f of x comma y defined as log x plus y upon x minus y? This will be f of capital X capital Y as log of capital X plus capital Y upon capital X minus capital Y, which after replacing x and y by xt and yt will become u f of xt yt as log xt plus yt upon xt minus yt, which will be log of, after cancelling this t from numerator and denominator, will become x plus y upon x minus y, which we can write as t raised to 0, which is 1 log of x plus y upon x minus y, which is in the form some power of t times f small xy. Hence, we can say that this function is homogeneous with degree 0. Next, consider another function u f x y z defined as sine inverse of x square plus y square plus z square upon x cube plus y cube plus z cube, which after replacing small xyz by capital XYZ will become sine inverse of capital X square plus y square plus z square upon x cube plus y cube plus z cube, and this after replacing capital XYZ by xt, yt and zt will become sine inverse of x square t square plus y square t square plus z square t square upon x cube t cube plus y cube t cube plus z cube t cube, which will be sine inverse of 1 upon t or t raised to minus 1 of x square plus y square plus z square upon x cube plus y cube plus z cube, which is not in the form t raised to minus 1 f of x, y, z, the original function. This is not a homogeneous function. So, the takeaway of all this discussion is we should be able to write the original function f capital X, Y, Z as some power of t times the original function f small x, y, z. Then only we can say that given function is homogeneous, not otherwise. This is part 1 of Euler's theorem. Euler's theorem can be applied on homogeneous functions only. So far we have understood how to recognize a homogeneous function. From part 2 onwards, we shall be studying Euler's theorem and how to apply it on homogeneous functions. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.